integers.
Guys, I'm recording. I remember the end of grade 6. I remember this specifically. It was the end of the school year of grade 6. We were all getting ready to start, you're ending for the summer and you start talking about what next year is going to look like. And when we come back 2 months from now, what's it going to be like? It was fascinating that we were going to be starting to be able to use pens to do work. We had to use pencils for everything before, and that, they were going to let us use pens. We also were told by the grade 7s, there's numbers that are less than, hold on one second. So yes, the concept was, oh my, and I was like, that's impossible. How can you possibly have less than nothing? Well, at the time, you hadn't really understood and how to represent something like a debt when you owed something. So that was kind of an eye-awakening thing for me, enough so that I remember the ooh and ah, that what does that mean, less than 0? You know, once you actually learn about it, it's not that much magic or mystery. It's fairly straightforward. It's just working through on the other side of the number line. Now last year, what you guys learned about was to take an integer, which is, does anybody have a definition for an integer for me? Go ahead.
Even integer is any number that moves slightly to the right or left on the number line.
Yeah.
I'm gonna take a guess.
Okay.
Like a number above or below 0.
Okay. Josh?
Positive or
Yeah, I'm missing something. You guys have all said the same thing so far. Just different ways of saying the same thing. You're missing one component to integer per se, yeah?
negative. Numbers that can be represented on a number line.
Numbers on either side of 0?
I feel like a thesaurus here, and I'm like asking for different ways of saying the same thing. You guys are saying the same thing. What's special specifically about an integer? Yeah?
Any
Look at all the numbers you're dealing with on here. What do you not see?
number that is not a decimal or fraction that can be represented on either the right or left side of the number.
There's the key, okay? There's no decimals and there's no fractions. Now later on, when you move through mathematics, when we say integers, it's more along the lines of what you guys were saying. Because we're dealing with the rules of integers. The problem is that whole numbers are very limiting in their ability to describe the world. We need portions of wholes in order to really describe what's going on around us. So when we say integers later on, it's exactly what you guys were saying. It's kind of positive and negative numbers to have to deal with. But specifically in grade 7 and grade 8, as we move through these concepts, because we have to understand how they behave, it's any whole number, positive or negative. Now, in grade 7, you guys were introduced to integers, and you did things like adding and subtracting integers. How did you guys do this? What did you guys use? Tell me something that you remembered from working on that sheet from last year.
Use the three primary ways of doing it. The concrete, and that's all I remember concrete.
Good. Concrete means what? Anybody? You're using your hands, right? So you have like little things in front of you and you're manipulating them. Manipulatives is a concrete way of exploring a concept. So there's concretely, there's pictorially, and then there's symbolically. So those are the three ways of looking at almost any mathematics. You can do math with your hands. We can measure the length of the room and the height and the width, and then we could find out the area of this room if we really wanted to. That's a concrete application of something like a volume problem. We could draw a picture of it and label the picture, and that would be started the building blocks of of a pictorial representation of getting to the answer, we could just take the length, multiply the height, multiply the width, and we could symbolically, just using multiplication signs and numbers, come up with the volume of this room. So those are strategies in mathematics, absolutely. But when you were learning about these things, there were certain things, and they're right on your sheets, I'm looking at them on your sheets right now as I'm speaking, ways of being able to solve adding and subtracting integer problems. What was one of them?
Integer chips?
Yes, good. So, correct me if I'm wrong, but you had blue and red, yes?
Yes.
Okay. Red meant,
Positive.
okay, all right, I was just making sure. I wanted you guys to say it, because in my mind, blue is positive and red is negative, but I don't know. And again, it's just that they're opposites of each other, really, right? Like, you decide. In grade 9, you're going to have filled in and empty shapes. So there's no colors associated with it. It's either all filled in black or it's just an outline with a white on the inside. So you had red for positive, and then blue for negative. So we call these integer chips. What was another strategy that you would have to try and analyze a problem?
A number line.
Yes, absolutely. Number line is very useful here. A number line. So I could use a number line to solve this particular problem. Anything else? Any other strategy? I'm curious. I kind of even learned a bit of one in the last class. Yeah?
Just plain old math adding?
Yeah, like just using the symbols, right? Like this is a picture, this is pictorial, this is a picture, this is pictorial. What is this representing? If I were to write it in symbols, what would I write to represent this addition in symbols? So that's another way, is symbolically. What would I write? What is this?
Positive.
Positive 2. Okay, so I have positive 2. And I'm adding what to that? Negative 3. I'm adding a negative 3 to a positive 2. Now normally with a number up front like that, we don't normally put a positive on there. We just hello. Okay, thank you. We'll just say 2, which is implied positive 2, plus negative 3. So if I was using integer chips, what would I do here in order to use integer chips to solve this particular problem? Does anybody remember that? No? Yeah?
You make like 0 pairs, so
Beautiful. Go for it.
like one negative cancels out one positive.
So I'm going to take these guys and I'm going to overlap them with these guys, and then these guys are going to cancel each other out. These are 0 pairs. 0 pairs are 2 numbers that I add together to get 0. I won't lie to you, I just learned that like 2 years ago. My first year I taught grade 7 mathematics. That was my second year teaching grade 7 mathematics, but I'd never really heard of 0 pairs before. So 2 years ago, because I didn't do integers with you guys last year. I think it was Mrs. Matheson that took over class at that point. Eh? So these guys cancel out and give me 0. What would be left? Negative 1, just one negative 1 chip. So I guess pictorially we would say is equal to meh. Meh. The light does that in my bedroom when you turn it on. It's like this, it's got to warm up or something. It's just like you turn it on, it's just like this really faint light. May as well be off. And every time it turns on, I'm like, meh. Okay. What about the number line? What would I do with a number line in order to solve this particular problem? Walk me through this strategy, right?
So you draw arrows, so you do, because it's +2 first, you go to your right.
Good. You start on your first number. Just go to the first number on the number line, which is in the second position. Here you are. You start there. Then what?
And then you have to go back 3 spaces.
How do you know to go back?
It's negative. You have to go back.
Okay. But that can be a little bit different when we get to different kinds of problems. Normally, watch what happens. Adding means I would go higher. I would go bigger. Adding tells me to go bigger. A subtraction would tell me to go smaller. So technically, I'm in a bit of a conundrum here as to whether to go left or right. The way to resolve that is to just think of it like this. This says go to the right direction, and if this is negative, it's telling me, do the opposite of what you think you should be doing. This says go right. This says go right. This says go the opposite direction, which is left. If you think about it like that, it'll always work out on the number line for you. So I'm going to go right, no, left, 3 steps. 1, 2, 3. And it puts me at my answer, which is -1. Okay? That's how you use the number line. And we'll practice a little bit of all these things, except for we're actually kind of wanting to move grade 7 fairly quickly. Okay? We want to get to grade 8. Right? We want to be doing grade 8 stuff. So if I were to look at this piece right here, which is 2 plus minus 3, symbolically, in your mind, you are really going to be pulling out and going to some of these other strategies. Normally you are. But there is a way of cleaning this up and making it more accessible. Not acceptable, but accessible. Okay? The way to do that is, again, I just learned this from the other class. Even though I know the rule, they do this. This is what they told me. Maybe you heard of this before. Keep, change.
That's what we did in Miss Science class.
That's what you did in Miss Science class too,
I
right?
remember that.
That was sad.
Okay, and that's where I get, no wonder we have so much problems with the dividing fractions, which is keep, change, flip. Whereas this is keep, change, right? What does that mean? Keep, change. What do I change this into? Yeah?
You change the addition to the subtraction.
Good. So I get keep, change, and then change. What do I do with this? Yeah?
You turn the negative to a positive.
2 minus 3. Okay? 2 minus 3 is -1. Okay, so there's little tricks there that also help us. Is that what Matheson did too? Keep, change? No? Yeah, it's kind of the same thing. Is that what you did? You had Matheson? You had this?
No, we just changed the positive.
Okay. All right. Again, everybody's a little bit different, and I want to build on what you know, right? I want to build on what works for you. Integer chips, I got to tell you, are a little bit kind of gaga, right? At this stage of the game, number line is where it is at, okay? To be able to track and follow these things. Understanding how these pieces are fitting together is the best thing, I think. I look at it this way. Let me share what I think this should look like. I'm adding debt. Is adding debt a good thing or a bad thing? Negative. That's a negative thing. So when I add a debt, that's a minus. Which is exactly like your bang bang, chicka chicka, chicka laga laga bang bang. Or whatever you're doing. Or your keep change-a-roni, macaroni.
Oh!
Pepperoni. Okay. I think of negative numbers as debts, and it works out really, really, really well for me. Okay? I tell you, I have a physics degree. I should know. I can deal with negatives. What about this one? Let's try this one. They'll get a little bit more complicated. Let's do this example, please. Now, your response is generally going to be, I can just look at it and I can know. But chances are you actually work through a process in your head.
What's that?
Like a,
Is that a positive?
something was vibrating, I don't know what. Okay. What's the answer? Who have I not heard from today?
Me, Jerry, best friend.
Jared.
Jared.
I need help.
We don't have a Jerry in this class.
I need help.
We don't anymore, sorry. Yeah. +3. How'd you get that? You need to, this is the mastery component of it. You need to explain to me how you got it. It doesn't matter how you got it, but you need to explain to me how you got it, because I'll tell you right now, you had to get there somehow. That's the key to this.
I use like a number line in my head.
Yeah, right? And that's a fair answer. You get to the point, if you're mastery with this stuff in grade 7, you get to the point where you just look at that and you're kind of like, okay, well that's 3. But you are technically following that number line in your head. The number line in your head. You start here and you move over 5 squares, that puts you at positive 5. Or, Brett?
I had used just change, which turns it into a negative.
Okay, so
Negative
let's
plus a negative.
let's do that. So we could do a number line here for sure. You could do any strategy for sure. You wouldn't do integer chips, but I guess in some way somebody did. And let me tell you how they did the number line. They did the integer chips in their reasoning. Okay, so let's just use this as an example. If I started here at -2, because I start at the first number on the number line, this says move to the right. There's nothing telling me to do anything else but move to the right. 5 steps, 1, 2, 3, 4, 5, and that puts me at 3 as my answer. So my answer is 3. The other gentleman in the last class said this, well, I know that I can take 2 out of this and it'll fill the hole here. And that will leave me 3. So what this person is doing is they're using integer chips. Blue is negative, right? So they used integer chips and they said, okay, I need to pull 2 out of 5 in order to cancel these. So they used some 0 pairs here. There's a 0 pair. Looks like a funky alien with some killer shades. So there's some 0 pairs. Those disappear and cancel out. And what's left is a 3-eyed alien. Whatever you want to make of that. A very unimpressed 3-eyed alien.
The blue.
He's a punk, he's got a mohawk. Okay. Let's apply the keep, change, change thing and see what happens. If I keep this, I get -2. I'm going to change this to a minus, and then I'm going to change this to a minus. Is that how that works, the keep, change, change? Okay. Now, solve that problem for me. This is my problem with the keep, change, change thing. I turned something that was relatively easy into something that is actually a lot more complicated. So I don't feel like that keep, change, change strategy is always a good thing. It can take something complicated like this, keep this, change that to a positive, change that to positive 5. Change it to an easy to solve problem. But this one's like, how can you justify the keep, change, change for this one now?
Yes.
How?
If you think about it, some people would look at a situation where there's like 2 different integers and maybe look at that as a more difficult situation. Some people prefer to work when they're all in the same category of integers and prefer to work with them all on either the left side or all on either the right side. Some people's minds work better that way.
Okay.
What?
So, I'm sorry, but I don't know if there's anybody else in this room who would think that this is more complicated than this. Is there anybody that would argue that? I don't know. Oh, put your hand down. Yeah.
You're the
Yeah.
one.
Okay.
Well, I think your shoes are on to
All right. So, in this case, the keep, change, change, KCC. I don't feel like that is always working for us. I think if you're having trouble getting through the question, then if you were given something like this, then it would really make sense to take it and apply the keep, change, change. So if it's making it harder, see, I don't know how they taught this last year to be able to justify that. If it's making it harder, whoa, just go back to the way it was and work with it this way. If it's making it easier, if I was given this, keep this, change that, then I get a nice workable thing up top there. So just be careful when you apply the keep, change, change. According to what I said before, the way that I would like to look at a problem like this, I'm going to look at this nasty thing right here, and I can turn it back up into this, not with a keep, change, change, but with this. Getting rid of debt. Getting rid of debt. Good thing?
Yes.
Bad thing.
Good thing.
Good thing to get rid of debt. So these two things right here, looks like a sleepy happy guy with drool. The two negatives here,
See that?
getting rid of debt is a positive
And is
thing.
the thing in the middle of his nose?
No, it doesn't have a nose. That's why he's so upset.
But between the eyes, he has a
What are you
bracket.
looking at? Looking at the lights.
Yes, he fell on the stairs and his nose is impacted all the way up between his eyeballs.
That's eyebrow.
Okay.
That's fell down.
That's his eyebrow.
His eyebrows.
It's his choker.
Okay.
His eyebrows are supposed to.
One more example. This is the beauty of the way that I like to look at things. For me, I'm losing money. Good thing or bad thing? Bad thing. Okay? It takes me about 2 seconds to clean this up. Look at that, now he's winking. To turn that into a negative. Just by thinking about it as debts, getting rid of negative is a debt, subtraction is get rid of. Getting rid of a positive is a bad thing. Getting rid of a negative is a good thing. Okay. 5 minus 3 is 2.
5.
17.
Wow.
28.
So much mastery oozing out of this room.
Scare me now.
Okay.
The answer's 37.